So part C of this question is we have to find, by drawing the ball path, whether it goes over or under the crossbar. Now, the important pieces are that where this line AB intersects the goal line, if we go parallel to the z-axis, and we're told that it's 9 meters from the goal line. So that line, 9 meters, if we measure it, that's not a true length of that line, but this line here is a true length of it. So I can measure exactly 9 meters from the goal line here. Okay, so I'll have to move this over just so you see it clearly. So 9 meters from the goal line is here. So we're told from where the ball is kicked, which is in this location, it reaches a maximum height of 6 meters, having travelled a horizontal distance of 6 meters. So from here, we measure over 60 mil. I'm going to draw a vertical line up. Now remember, vertical would be in line with the uprights of this goalpost. Extend that up. So that would be a horizontal distance of 6 meters, and will reach a vertical distance of 6 meters. Okay, and the path of the ball is parabolic, and we're told that this point here would be the vertex of the parabola. So what I'm going to do now is I'm going to complete the rectangle that the parabola will be contained within. So going vertically up from there and horizontal across from the top. Okay, so like all parabolas, I would like to divide it up into 5 equal parts. So this is half the length of it. So 60 millimeters divided by 5 would be 12. So I'm measuring across in instances of 12 mil. And this is the axis of symmetry of my parabola. So parallel to the axis of symmetry, I'll bring a line, construction lines up from those 5 intervals. The height of this parabola is 60, so 60 divided by 5 is 12 again, so 12, 12, 12, 12. And as this is the vertex, and I'll just label that up there, this is V, the vertex of the parabola, you join the first division to the vertex, where it marks the first or intersects the first line, that's a point in your curve. So second, point in the curve. Draw the third line, third point, where it marks the, intersects the third line. Fourth point from the vertex, where it intersects the fourth line. So that's one side of my parabola drawn. So just like so. So there's one half of the ball play. So now I'm going to do an exact mirror image of that, and we'll see will the ball go over or under, and I think you can determine from this already that it's definitely going to go under. Alright, so as these are 12 millimeter units, I'm just going to measure 12. Just speed things up a bit, because all I want to see is whether it goes over or under the goalpost. 12 and another 12 mil, so that means just 3 of those. Construction lines up. And now I'm just going to take the same heights across. So we already have the height of the first point, that's where it intersects that line. Height of the second point, where it intersects the second line. Height of the third point intersects the third 12 millimeter line that I have over here. So I have there, there, and there. So from the vertex it continues in the downward direction here. So we can see now that the ball goes under. And that is the solution to part C.